Hello guys, you're welcome to Vin's Tech class. And in today's tutorial, I'm going to walk you through quality wine prediction. Now, the first thing we're going to do is to import our necessary module. First, we import our pandas as PD, we import NumPy as MP, we import Seaborn as SNS, we import Matplotlib as PLT, we import our print test split function from sklearn. We also import our random forest classifier, and finally we import our accuracy score function for model evaluation. And the next thing we're going to do is to load our datasets. Now in my own case, I have my dataset on my system. So if you have your dataset on your system, you copy the location of your dataset, and this is the location of my dataset. Next, you change the backward slash to a forward slash. But if you leave it the way it is, it's going to prompt an error message. So next is to use the head function to view the first 5 rows. You can observe this is our first 5 rows. But if you want to view more than first 5 rows, you can specify the number within this bracket. Let's say you want to view like the 7 5 rows. Sorry, the 7 first rows. You can specify your number within this bracket. Next is to see the shape of our dataset. And now, from the output, we have about 1,599 features. Sorry, 1,599 observations and 12 features or attributes. Next is to see the dataset information, the data type information of our dataset. And now, if you can observe, only the quality attribute is an integer data type. This is just the data type information of our datasets. Next is to check for null values. And now, if you can observe, we don't have any null value. Let's say we have a null value. You can use any imputation techniques to feed the null value. You can use a meaning imputation technique or k nearest neighbor to fill the null value. But in our case, we don't have any null value. Next is to use the describe function to view the statistical analysis of our datasets. This is the count, which is about 1,599 observations. This is the mean value for fixed acidity. This is standard deviation. This is the minimum value. And we also have the 25th percentile, which is less than 7.1. We also have the 50th percentile, which is less than 7.9. We also have the 75th percentile, which is less than 9.2. And we also have the maximum value, which is about 15.9. That is the statistical analysis of our dataset using the describe function. Next is to check for outliers using a box plot. Now, outliers are observations that are different from normal observation within the dataset. And these outliers could be due to error in measurement or variability in measurement. But in one case, we ignore this observation since it's not going to affect the outcome of our project. Next is to use the cat plot to view the distribution of our quality observations. That is, we use the cat plot to view the distribution of quality observations. Here we have 3, 4, 5, 6, 7, and 8, and it's more on 5 and 6. Next, we use the bar plot to see the relationship between the volatile acidity and the quality attribute. Now, if you can observe, as the volatile acidity is increasing, the quality is decreasing. showing that they are inversely proportional to each other. We also see further data analysis. Now let's observe for the citric acid and the quality attribute. Now, as the citric acid is increasing, the quality attribute is also increasing, showing that they are directly proportional to each other. You can also experiment with other features to see its relationship with the quality attribute. That is our target variable. Next is our correlation matrix. Now let's observe from this color bar. If you observe this color bar, this part is darker, showing that values closer to this part are directly proportional to each other. That is, as one value is increasing, the other value is also increasing, showing that they are directly proportional to each other. That is, they are showing a positive correlation. Now let's observe the lower part of the color bar. Now if you observe the lower part of this color bar, this part is brighter, showing a negative correlation. That is, as one variable is increasing, the other variable is also decreasing, showing that they are negatively correlated. Now let's observe our features. Now observe this color matrix. We have our feature on the vertical part and also on the horizontal part. Now let's observe for alcohol and quality, which is about 0.5. That is, they are directly proportional to each other. That is, as the alcoholic content is increasing, the quality is also increasing, showing that they are directly proportional to each other. Now let's also observe for total sulfur dioxide and with free sulfur dioxide, which is about 0.7, showing that they are directly proportional to each other. That is, as the total sulfur dioxide is increasing, the free sulfur dioxide is also increasing, showing a positive correlation. Let's also observe for pH. For pH and fixed acidity, which gave us a value of about 0.7, showing that they are negatively correlated. That is, as the pH value is increasing, the fixed acidity will be decreasing, showing that they are inversely proportional to each other. That is all for correlation matrix. And that's all for data analysis part. Now let's move into the data preprocessing part. First, we drop the quality attribute. Now observe from the features. Our quality attribute cannot be found here. It has been dropped. That is just a step in data preprocessing. Next is to carry out what we call label binarization. That is, if the quality attribute is greater than or equals to 7, it should be 1. X, it should be 0. Now let's observe our the distribution of the quality features. Sorry, the distribution of the quality observations. We have 3, 4, 5, 6, 7, and 8. That is, if these values are greater than or equals to 7, it should be 1. S, it should be 0. That is what we call label binarization in machine learning. And it's mostly used when the values for the target variable are different. That's an example of a label binarization. That is, if our quality attribute is greater than or equals to 7, it should be 1. S, it should be 0. And if you can see from the output, we have 0 values. Next is to use the train test split function to divide our dataset into training and testing. And we have our test size to be 0.2. That is, 20% of our data will be used for testing, while 80% will be used for training the data. And we have our random state to be 42. And this is the shape of our original value, which is about 1,599 observations. This is the shape of our Y train and Y test. Next, we train our model. We build our model, the random forest classifier. Next, we fit our model into the X train and the Y train. Next, this is our model will predict the X text. and it will be stored in this x-test spread variable. Now we use the accuracy score function to compare the predicted value and our original value, which gave us an accuracy of about 91.25%, showing that our model is performing well. But if you want to further improve the accuracy of your model, you can add more data or carry out what we call hyperparameter tuning to improve the accuracy of your model. So guys, that's all for today's tutorial. If you have any question, leave them in the comment section below. And don't forget to subscribe to my YouTube channel. Thank you.